Hello guys, and welcome to a fifth video on Python programming. In our last video we're discussing about the different operators that we have in Python programming language. Remember that we have the arithmetic operators, which were the addition sign, the subtraction sign, the multiplication sign, the division sign, the floor division sign, then the modulo sign. Okay, these were the 6 different arithmetic operators that we have, and we were able to see how each of these operators are used in diverse Python areas of application. From there, we went on to discuss the different assignment operators that we have. We also saw the differences between them. That arithmetic operators are used to assign new values either to an existing variable or to a new variable, whereas assignment operators are used to assign new values to an existing variable. So by assignment operators, you are changing the old value of a variable and giving it a completely new value. And we saw some of them, that these were some of them: plus or equal to, minus or equal to, multiplication or equal to, division or equal to, floor division or equal to, and the modulus or equal to. These are the different assignment operators that we have in Python. And just for emphasis, I need to point out something about the division operator, arithmetic operator in Python. Now, the way this operator works is quite different for Python versions 2 and versions 3. Let me demonstrate something to you. Currently, this is Python 2 that I'm running on my system. If I were to do a computation like this, to print value of 24 divided by 7 using the default division pattern that Python uses, if I were to run this, you see my answer would come out as an integer, a round whole number integer, because this is Python versions 2. If I were to do this as well, there would be no difference between the two. The values will still come out the same. But with Python 3, the actions are a bit different. Let me illustrate that. First of all, let me switch my Python interpreter to Python 3. This is Python 3. So for those of you who do not have Python 3, you need to install it and apply it before you can see that work. Just give it a second. It's processing, trying to change over to Python 3. Alright, now it's switched over to Python 3 successfully. Now I want to demonstrate this again. Now, using this division again, now this is going to give you the whole number plus the decimal points included. So this is some of the differences that Python 3 has to offer as opposed to Python's versions 2. Now, whereas if you were to want to do the floor division, this now would give you just the whole number equivalent and will neglect the decimal points aspect of it. So with Python versions 3, this gives you only the integer rounded whole number, whereas this gives you the whole number along with all the decimal points that go along with it. Now let me switch back to my Python versions 2 to be able to, going back to Python versions 2, I apply this and I OK. Just give it some time. Alright, so going back to Python's versions 2, by the time you perform this division, you're going to have your answer as a whole number. And likewise, when you perform the floor division, you're going to have your value as a whole number. Now, in order for you to have that effect of seeing your decimal point values as you make the division, you're going to have to call that Python 3 function that makes it possible for you to see decimal numbers attached to the whole number. And that was where this particular code, import code, from future import division, that's where this comes in, because you are now importing this functionality from Python versions 3, and you want to bring it over to Python versions 2. So by the time you run this now, you're going to have your decimal points equivalent. So just take note of that. I just thought I should create that point and help you appreciate that point before I go on. Alright, now after the assignment operators that we looked at in Python, we also looked at what we call, alright, now after the assignment operators, we did look at the comparison operators that we have in Python. Alright, so we're looking at the assignment operators, and we looked at the comparison operators, which are used to compare two different variables, the kind of values that they have, and to see if the values meet some form of conditions. Now, the comparison operators that we have in Python, we have the less than, we have the greater than, we have the less than or equal to, we have the greater than or equal to, then we also have equal to sign, and as well as not equal to sign. That's 1, 2, 3, 4, 5, 6 different comparison operators in Python. We saw that these operators are used to test the values of two variables in Python. So if I were to have a is equals to 10, b is equals to 12, I can use these assignment operators. If a is less than or equal to b, then I would want to do a particular activity. So these assignment operators, comparison operators, will now check between these two variables, variable a and variable b, find out that the values meet a particular comparison operator, and then do the required action. That was it for the comparison operators. Then we also have what's called the logical operators, being the and, the or, and the not. These are the three logical operators that we have in Python, and these logical operators are used to virtually check the test between 2 or 3 different, as many conditional statements that we can have in Python. So if I were to have something like this, like a is equals to 12, n is equals to 13, I can use this logical operators and or to test 2 or more conditional statements. So I can say if a is less than n and a is equal to n, or as many of them as they can be, then I can put a particular action that I want to take if this condition comes out as true, or if it comes out as false, a substitute action that I can take, which I can also want to print a particular activity that would come out separately. So these are AND statements. You can also use an OR, you can also use whatever that you want to use. But for the not is virtually used to check, to test a single variable to know if it's the opposite of its value. We'll get to that when we get to bitwise operators. And speaking of bitwise operators, we have the AND, which is given by this symbol in order to differentiate AND operators from AND logical operators from the AND bitwise operator. The AND there is symbolized by this symbol. Okay, where is it? Yeah, that is the AND for bitwise operators. And then for the OR, we have this as the OR for bitwise operators. That's this symbol. Now, like I said, these are bitwise operators. Now, the good thing about bitwise operators, which is different from the logical AND, is that bitwise operators, they work on the bits of each single value. Now, what I mean by that is this: if I create a variable, say a is equals to 10, this variable a has the value of 10. Okay, so the value of a is 10, and inside this memory location of a, the value we have there is the value of 10 or 9 or whatever that it is there. Now, now coming to bitwise, when you want to look at it in terms of bitwise, let's say a has the value of 1, okay, has the value of 1, and then let's say b has the value of 2, okay. Let's say a has the value of 1 and b has the value of 2. Now in Python, these two values, a and b, their values are 1 and 2 respectively. Okay, but if we want to put it in terms of, it means we're going to have the value of a in the bit format being 1, that's convert 1 into bit format, and the value of b being 2, we're going to convert that into bit format. Okay. Alright, so in this case now, if you convert 1 in bits, if you can remember your binary conversion, 1 would have the value of 001, whereas 0 will have the value of 000. Then 2 would have the value of 010. These are bits conversions of each and every one of these single numbers. So this is going to make it show how we convert bits and provide information in terms of bits, bitwise operators, and see how they work. Now in the case of this, so assuming we want to do a bitwise, let's say we want to find the value of a and b. Sorry, we want to find the value of a and b in terms of bitwise operations. Now if you print this, you're going to see the answer is going to come out as 0. So the question now is, how does a and b give the answer as 0? A bitwise, b give that's bitwise, and how does it give a value of 0 given that a is 1 and b is 2? Now look at it this way. Okay, let me separate this so that will make it easier. Now this is the value of a being 1 and this is the value of b being 2. Now with bitwise operators, a 0 and a 0 will result into a 0. A 0 and a 1, for an AND, this will result into a 0. And then a 1 and a 0 will result into a 0. That's with bitwise AND. So with bitwise AND, in order for you to have a 1 as an output, the two values are going to have 1 and 1 before you can have a 1 as an output. So that explains why 000 comes out as 0, and our final answer here is coming out as a 0, because this is 0, 0 and 0 gives 0, 0 and 1 gives 0, 1 and 0 gives 0 as well. So the final answer comes out as 000, which has the value of 0. Now let's look at OR, what this will look like. Now for OR, in order to have a value of 1, either one of the variables in the two operands would have to have a value of 1. So in this case, 0 and 0 would give 0, 0 and 1 would give 1, and then 1 and 0 would give 1. So if you would print this answer out, you'll have a value of 3, which the binary equivalent of 3, which is 0 and 1 when it comes to binary equivalent. That's how bitwise operators work. It works with the bits on each and every one of the numbers, each and every one, be it characters, be it numbers, be it strings, whatever you're feeding it to, it converts it into the bits and then works with it based on bit. Then you also have the exclusive OR. It has this symbol. That's also for a binary bit operator. So if I will put this on this, A or X or B, now what that one does is, where you have 0 and 0, that will give you 1. But when you have a 0 or a 1, that's where you have, okay, hold on, let me confirm that. Okay, yeah. So where you have a 0 or a 1, where you have different values, that is where you have 1. But where you have similar values, this will convert or be translated into 0. So a 1 and 1 would give 0, a 0 and a 0 will give 0. That is bitwise XOR. It's usually typed like this, XOR, exclusive OR. So with the exclusive OR between A and B, 0 and 0 would give a 0, 0 and a 1 would give a 1, and then 1 and a 0 would give a 1. So if you print this, you would also have a value of 3, which is a bit similar to the normal OR. So the difference between exclusive OR and the normal OR, that is between exclusive OR, OR and the exclusive OR, the difference between these two and the similarity between these two. Now, the similarity there is that when there is a 1 and a 0, you have a value of 0. Okay, a 1 and a 0 will give a value of 1. Sorry, be it 1 and a 0 or 0 and a 1, they give you a value of 1. But with the normal OR, a 0 and a 0 would give you a value of 0, whereas a 1 and a 1 would give you a value of 1. But with exclusive OR, similar variables would give you a value of 0. So if you were to perform an exclusive OR as well as a normal regular OR on these two variables, what you'd have here for a normal OR, you'd have 0, 1, 1, 1. This is the value of a normal OR. These are the values you likely have with a normal OR, but when you now want to come over to an exclusive OR, similar values will result in a 0. So this will be a 0, 1, 1, and then 0. Similar values. So that is the difference between normal OR and the exclusive OR. Then we also have the shift operators, which are also part of bitwise operators in Python, and those have this symbol. This is the right shift operator, and then this being the left shift operator. So these two also work on bitwise level. What they do is they shift the values by a particular number. Okay, let me just demonstrate how this works. Now, assuming A has a value of 1, A is equal to 1, and then B is equals to 2. Now, performing a shift operation, if you want to print A, remember Python is case sensitive, so if you type small a instead of capital A, that's going to be an error. Right shift, let's say by 1. If you print this out, the answer you're going to get is 0. So the question now is, how does A right shift by 1 give you an answer of 0? Now let's look at this, looking at it from the bitwise angle. Now 1 has this as a value 001, whereas 2, okay, yeah, 1 has a value of 001. So by saying A right shift 1, it means the very first value of the last value in the bit should be shifted by this number of times. So it should be shifted just once. So what that now does is it takes the last value here and then shifts it out. So once it shifts this will now be replaced and you'd have 000. So once that is done, 000 is the equivalent of 0 in binary digits, which gives you a value of 0. And the same way applies with left shift. If you want to shift by 1, this is the value of 1 in binary format, and then if you want to shift this one place, it means 1 would come here, and then here will be left with 0. So left shifting 1 by 1 place will give you a 010. So basically, if you run this now, having shifted 1, A, the value of A in bits by 1 place, if you left shifted, if you run this now, your answer would give you 2, which is the binary equivalent of 010. Okay, so that's it for for the bitwise operators that we have in Python. Then the other operators we now have are operators that are used either to test the type of object that the variable is, or to test whether an object. Okay, Okay, so after those operators that we've looked at arithmetic operators, we've looked at assignment operators, comparison operators, logical operators, bitwise operators, and the last two remaining are identity operators and membership operators. For identity operators, we have the is as well as the is not. Now, as the name implies, this what's it called? These identity operators are used to find out if a particular object belongs to the same object class as another particular object. So as we want to test two variables if they're the same objects. Okay, let's see. If we have our a is equals to 5, 6, and b equals to 8, and you say if a is b, then we want to print yes it is, yes it is. Else you want to print no it is not. So if you run this program now, so what this means is a is not an object of the b. That's why it prints this particular line of the project. So if a was somehow a subclass of b, like anyway, we get to really see how this is used when we get into object, because these are used to test if an object is a subclass. These are used to test if an object is a subclass of a particular superclass. That's where identity operators are usually used in Python to test if a particular, like saying if a child is from a particular man, if a woman, a daughter is from a particular man, that kind of thing, or is not from a particular. So it's used to test a subclass and a superclass if a subclass inherits from a superclass. That's basically where it is. But for membership operators, sorry about that, for membership operators like in and not in, these operators are used to test if a particular value is in a collection or a particular data structure. For example, if I have a list of numbers, let's say list of integer numbers, and I want to test if a particular number is among the collection of numbers that we have here. So I can say if 50 is in J, then print yes, else prints no. So what this will do is it'll check among this collection of numbers if number 50 is inside it, and will print a no. This is for this, no is for this. Whereas if you want to say if 50 not in J, so it will definitely print yes there to tell you that 50 is not in this number. So those are the different operators that we have in Python, and we've looked at them extensively. We've seen areas where they're used and areas where they can be applied. So if you have any questions on this, anything at all about any of the operators that you don't understand clearly, feel free to write me up and then send me a message, and I'll produce another video to explain it thoroughly. The next topic we're going to discuss in the next video is going to be on the different data types that we have in Python. So look forward to another video, or expect a video on that, and we'll be able to cover as many, in fact all the data types and the data structures that we have in Python, and we're going to see how they are used. So thank you for watching once again, and look forward to seeing you all in our next video.